Question number 1. An enterprise network implements in NAT64 to allow IPv6 only devices to access those IPv4 resources. A network administrator notices that specific applications fail to connect, even though NAT64 configuration appears to be correct. What is most likely the cause of the issue? This comes into that troubleshooting specific areas that CompTIA comes in and requests that you have when you're going through it. People often ask me, they're like, well, is it like this for Security Plus? No, I actually feel that Network Plus is a more difficult exam than Security Plus, believe it or not. I feel like you have to understand a lot more to it. Even though Network Plus is considered to be a lower tier exam, a lower tier certification goes through it. But yeah, let's answer this one, shall we? All right, so what is most likely the cause of this issue where we've got IPv6 not able to access or fail to connecting on some IPv4 applications? Of course, let's start with A. The DNS64 server is not translating quadruple A records to A records. I don't think so. I don't think that's going to be a good answer for that one for obvious reasons. What about B? The applications are using hard-coded IPv4 addresses. Maybe. I mean, if it's using IPv4 hard-coded, then maybe it won't allow for NAT64 to work for IPv6. Could be a good answer. C, the NAT64 gateway does not support stateful NAT64. Could be another good answer. And then the IPv6 prefix used for translation is invalid. I think if IPv6 prefix was not used for translation, then I think we would see a lot more problems, right? If that was indeed the case. And so it really comes between B and C. I'll give you about 5 seconds to answer this one to figure it out if you guessed A or D. Obviously not going to be A or D. It's going to be B or C. What do you think? All right, let's answer this one, shall we? If you guessed C, NAT64 gateway does not support stateful NAT64, you would be incorrect, unfortunately. So why is it B then? Why is it B? Well, NAT64 relies on DNS64 to translate domain names from IPv4 to IPv6, and so the IP4 addresses bypass the DNS, causing the connection to fail. That means that if the application is hard-coded into IPv4, we're not going to see that translation. We're not going to see that problem, right? That hard-coded IPv4 address bypassing the DNS. And so, B is going to be our answer. There it is. All right, question number 2. Network engineer deploys a captive portal for guest Wi-Fi access, typically something we do. Users report that they cannot load the portal on HTTPS websites after connecting to the network. What configuration change should the engineer make to resolve the issue? What should the network engineer change to resolve this issue? What do you think about this one? I know it's a little bit more difficult. I'm trying to stump people. I'm gonna be honest with you. My goal is to stump you. That of course is my goal. Because if I stump you, then I've done something and you realize, hey, I need a little bit more studying. But if you get them all right and you're like, I got these, Dr. K. I don't know what you're talking about. This was easy. Then I think if you haven't already passed your exam, maybe you should look into passing it very soon. I think you'd be set to go, because these are not easy questions, at least on this episode. Let's tackle this one. What configuration change should the network engineer make to resolve this issue? Let's start with A. Redirect all HTTPS traffic to an internal HTTP-based web server. I mean, you could do that. You could, and it might actually work, but here's the problem. Right? First off, it's a captive portal for Wi-Fi access. And so, is it really going to work? And then secondly, the problem is that we want HTTPS because it's secure, it encrypts that traffic, and if we put it to an internal HTTPS web server, not really going to accomplish what we want. So I don't think that's going to be a good answer. B, ensure the DNS server resolves all queries to the captive portal's IP address. Ooh, another good answer. Then we have C, configure SSL certificates for the captive portal login page. Ooh, is that causing an issue? Could be. C is another good answer. And then D, block HTTPS traffic on the guest network until authentication is complete. We could do that. That would actually fix the issue, I think. But is it a good way of doing it? So we got B, C, and D are all, I think, decent answers. We got to get rid of one. Should we get rid of C? Let's get rid of B. Ensure the DNS server resolves all queries to the captive portal's IP address. I feel like that's an easy one to get rid of because the DNS server resolves all queries to the captive portal's IP address. If we read the question carefully, we could see that the users report that they cannot load the portal on HTTPS websites after connecting to the network. Kind of points that that's not the issue. And so it's got to come between C and D. C and D are going to be our best top two answers on the board. Let's see if you go. And I'm going to give you about 5 seconds. 5 seconds. Yeah, let's answer this one. If you said C, configure SSL certificates for the captive portal login page, you would be correct. Yes, I hope I stumped you. I hope I did. I hope I tricked you. If I did, I'm going to take that as a personal pat on my own back. But no, it's not block HTTPS web traffic on the guest network until authentication is complete. We want HTTPS. I want you to think about this, right? We want the traffic to be encrypted because otherwise, man-in-the-middle attack easily pick up that information. That's not what we want. I went the wrong way. Oops. There we go. Let's go back. There we go. There it is. There it is. Configure SSL certificates on the captive portal. Question number 3. A network administrator attempts to configure a managed switch through the web-based GUI but cannot access the interface. A quick check reveals that the switch is reachable via SSH. Which of the following is most likely the cause of this issue? What is most likely the cause of this issue? What do you think about this one? Now, I've been told numerous times that I take too long in these, so we're going to just move on. We're going to move forward. Let's answer this one. Of course, if you need more time, you can pause that video. Let's start with A, shall we? Web service on the switch is disabled. Is the web service on the switch disabled? Is that a possibility? Maybe. B, the management VLAN is misconfigured. Another great answer. I do like this one. C, HTTPS is not enabled and the browser blocks HTTP access. Okay, that makes no sense whatsoever, right? HTTPS is not enabled and the browser blocks HTTPS traffic. Only if we're trying to do it out through a web portal. And this, I mean, I guess you could say maybe. I just don't see this one. I'm going to say no. D, the switch's IP address needs to be properly assigned. Does it? I would say that if you're able to connect via SSH, that the IP address is accurate because you're going to use the IP address for SSH. Obviously, if you can connect via SSH, then you have the IP address correct. So that kind of rules that one out. Really comes between A and B at this point. A and B are going to be the top answers on the board for this one. I'm going to be about 5 seconds. About 5 seconds on this one. Between A and B. Well, if you said B, the management VLAN is misconfigured, you'd be incorrect. It is A. The web service on the switch is disabled if you connect via SSH, right? So we're able to go in through SSH. We're able to get that command line interface. But when we try to do it through the web interface, the GUI isn't showing up. That means that there's a problem with the web service because the GUI, right, the web service is responsible for hosting that GUI. That's going to be a problem, which means the web service on the switch is disabled. That's going to be our answer. There it is. It's going to be A. A is going to be the right answer on this one. There it is. All right, question number 4. A network experiences frequent IP conflicts. What is most likely the cause of this issue? What's most likely the cause of our issue here? What do we think? We've got DHCP discover. We see a little bit going on there. We see the DHCP offer. We see the request, and then we see the decline. So what is most likely the cause of this issue? I'll give you a second to read through this because I know there's a lot of information on there as you're going through. But again, you can pause that video. And so we're going to answer this one. We're going to start with A again. Another DHCP server assigns conflicting IPs. I should have capitalized the P. That's okay. IPs to the same network. Maybe it's a good answer. B, the DHCP lease time is set too low, causing rapid IP reassignment. And so here's how I do this, right? Anytime I read an answer, I'm looking back at that log because they're giving me a log, right? So let's do that with B. The DHCP lease time is set too low, causing rapid IP reassignment. But if we see this, there's nothing in there for IP reassignment. We're not seeing multiple discoveries. We're not seeing multiple offers. And so that can't be an answer. C, the offered IP address is already in use by a static assignment. Is that a possibility? And then D, the DHCP server's pool is exhausted, resulting in reused IP addresses. And again, is that a probable thing? And so we really have to understand the logs as we're going through this. So let's do this, right? Because we have A, C, and D as possible answers. Let's get rid of A. Another DHCP server assigns conflicting IPs to the same network. We're not seeing that. If we were, we'd see multiple DHCP offers, right? We see multiple declines associated with that, and so we don't have multiple DHCP servers assigned. That's really not something we're seeing here. So that really leaves it between, what do we got? What do we say? C and D. C and D are gonna be the top two answers on the board for this one. C and D. I'm only gonna give you about 5 seconds. About 5 seconds. All right, let's tackle this one. Let's see. C, the offered IP address is already used by a static IP address. If we look at the log, right? If we look at the log, we can see here offered from 00112233 yada yada yada, and then we see DHCP offer, right? So that was discovered. This was the offer. 192.168.100. We see a request for that 192.1.100, and then we see that declined. So does that make sense? Yeah, it does, because the offered IP address, which is 192.168.1.100, right? And then we see a request simultaneously, okay? Because they're within 5 seconds of each other. And then we see a decline, meaning that our DHCP server, which, by the way, we see that right there, this MAC address, is declining to give that because there's already one in use. And most likely because of a static IP address associated with it. That means that as the offer comes in, we can see that it's already in use by a static IP address, and that's where we're seeing that decline. So why isn't it this one? DHCP's pool server exhausted, resulting in reused IPs. It doesn't do that. It doesn't reuse IP addresses. That's not the error we would see on this. And so this is the only one that makes sense. C is the only one that makes sense. C is going to be our answer. There it is. All right, question number 5. Question number 5, last question for the day, of course. A video conferencing application frequently experiences choppy audio and delayed frames. What is the primary cause of the poor application performance? What do you think on this one? We have quite the log here. We see a packet loss. We see some latency, min and max. We see a little bit of jitter, a little bit of bandwidth, some codec showing opus. We see packet size 120 bytes, and we see RTP sequence gaps are detected. So what is the problem here? What's the problem here? I mean, quite a bit of a log here. You almost have to know what you're looking at as you're going through it. I'm gonna give you like 5 seconds, so we're gonna tackle this one. Maybe I should give you 10. I don't know. I'll just keep on talking until we figure it out. Let's tackle it. Let's tackle it. If you need more time, of course, you know where that pause video is. What is the primary cause of the poor application performance? And because there's so much going on in this log, how I would answer this one if I was looking at an exam is I'd start with A and I go, okay, insufficient bandwidth for the application. Where's my bandwidth? It's at 50 megabytes per second. There is literally almost no application that I could possibly think in my mind that requires more than 50 megabytes per second. I just don't see it. And so A, out the window. Obviously not going to be, in my opinion, a good answer for this one. Moving on. High jitter affecting the delivery of the audio and video. We look at jitter, 85 milliseconds. Could that be a cause? Could that be a cause? I think it could. Is there a better answer, though? C, latency exceeding acceptable thresholds for real-time communication. We look at that latency, we're seeing average is 35 milliseconds, but the maximum is 100 milliseconds. Is it possible that when we are going through this, right, our application can't effectively move forward with 100 millisecond latency? Because it is the maximum, which means it is occurring. And so C is very, very real opportunity. Is it? Is it, though? Right? Which one makes more sense, B or C? And then D, packet loss causing retransmission and data corruption. We look at this, we're not seeing anything that points out to packet loss, right? We see 0.1%. That's literally, what is that, 1 in 1,000? I don't think so. So it really comes between B and C. B and C are going to be our best answers on the board. And we're just going to dive into this. If you said C, latency exceeding acceptable thresholds for real-time communication, no. It's just because it says the maximum is 100 milliseconds doesn't mean that we're getting it. We see spikes like that all the time. But the average is what we're looking at. The average is 35 milliseconds, well within the defined guidelines for almost any application. But the jitter at 85 milliseconds, that is a problem, right? It's excessive for real-time communication. It's going to disrupt our arrival timing of our packets. It's going to lead into some delayed frames, some choppy audio, some other problems with it. And if we look at the question, it says a video conferencing application frequently experiences choppy audio and delayed frames. That's where jitter comes into play. It is going to be 100% B. B is going to be your correct answer on this one. I hope you found this educational. As always, I'm Dr. K. Until next time, we'll see you again.